Welcome everyone. I hope you're doing well. Today we want to explain what is the relationship between the unit circle and the trigonometric equations. Basically, a few weeks ago, we learned how to sketch the graph of the six trigonometric functions. And you know how to graph sine, cosine, tangent, and their reciprocal trigonometric functions. That will be cosecant, secant, and cotangent. And also, we learned how to prove the trigonometric identities. You learn how to use proving trigonometric identities using the reciprocal identities, Pythagorean identities, addition, subtraction formulas, double angle, half angle, lowering powers, sum to product, and product to sum. And today we're going to learn how to solving trigonometric equations by means of the unit circle. Well, actually the unit circle, when we're talking about the unit circle, the first thing that we must do or we must do apply is the concept of the circle. Remember, a circle can be defined for a set of points that will be located in the same plane, but every point are equidistant. What does that mean? That means they have the same distance of one singular point that we call center. Okay, and the distance between the center for any point of the circle, we call that one radius. So this is the equation of the circle with the center of the origin and radius r. Okay, but because we're talking about the unit circle, the name of the unit circle is because the maximum value of the radius of this circle, that will be 1. For that reason, the general equation of the unit circle is given by x squared plus y squared, that will be equal 1. Same happened with the Pythagorean theorem. If you remember, the Pythagorean theorem is derived from the unit circle. Sine squared theta plus cosine squared theta, that will be 1. Actually, this is a polar coordinate you're going to learn if God wills a few years later if you're studying the engineering, right? But basically, both this is a polar equation for, and this is the algebraical equation of the circle for the both are equals 1 because we refers of the unit circle, okay? Basically, at the moment going to grow, working with trigonometric equations, um, and basically the main idea is trying to looking for the value of the angles for the different quadrants using the reference angles. What are the reference angles? The reference angles given ingredients are given by pi 4, pi 6, pi third, and pi half radius. All of them has belongs to one singular family that will be located in the four quadrants of the coordinate plane or on the unit circle. Remember, pi 4 represents 45 degrees, pi 6 represents 30 degrees, pi third 60 degrees, and pi half belongs to the family of the 90 degrees. Okay, so this is four quadrants given value that represents one complete period, okay, using the six trigonometric functions. And according for this one complete period, we have the four quadrants for any family. You know, four quadrants or the coordinate plane. For that reason, we're going to have 4 families times 4. We got 16 families complete using the reference angle of the unit circle. For example, in the first quadrant, we're going to locate the values of pi 4. And the given values already for pi 4 or 45 degrees is given by, for example, sine of pi 4 will be square root 2 over 2, cosine pi 4 will be square root 2 over 2, tangent will be 1, cosecant will be square root 2, secant square root 2, and cotangent, that will be 1. Those values are given. And as soon as you can see, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Um, the next three angles located in the second, third, and fourth quadrant have the same values. Okay, what will be the difference between them? Is the position on the quadrant. Remember, the function sine belong to the y-axis. The y-axis, and cosine represents the x-axis. For that reason, in the first and second quadrant, in the coordinate plane, y-axis is positive, and the x-axis in the first quadrant is positive, second quadrant is negative. In the third quadrant, fourth quadrant, uh, the y-axis is negative, and the x-axis in the third quadrant is negative, and the fourth quadrant that will be positive. So as soon as you can see this table that represents the four angles that complete the one circle period, one singularity period, are values that you're supposed to have at the region of your hand. Because at the moment going to apply the trigonometric equations, um, and the calculator will be unuseful. What I'm talking about, in the calculator are given the given values that will be provided, that will be counterclockwise and clockwise, but only the one singular quadrant. But depending what the problem says, is located in the first quadrant, second quadrant, third quadrant, fourth quadrant, you're going to use one of these values that have one complete period. For example, let me show you one singular demonstration. For example, if you really want to know what will be the value of the secant of 7 pi over 6, well, actually, according to this table, the cosecant of 7 pi over 6 is negative 2, right? Well, if you really want to prove that situation using the calculator, well, simple. That's going to provide a demonstration. Okay, so let me see. Okay, we have secant 7 pi over 6. As soon as you can see the picture, there is no secant function. Okay, remember secant is the reciprocal value of sine. So one of them, if you want to evaluate that function, you must grind your calculator 1 over sine. But before to do that, make sure your calculator must be set up in radius mode. In this mode of the calculator, you're going to push the shift button and mode and push the option number 4, that will be radius. Okay, how this has been set up already. Okay, now let's going to evaluate secant of 7 pi over 6. Well, and remember, secant is 1 over sine. For that reason, 1 over sine, parentheses, 7 shift pi over 6. Well, let's see what will be the value that we got. Well, let me see it. Oh, voila. That will be negative 2. In this situation, you can check the values. Well, actually, that's going to stop sharing screen. And let's going to check the answer. Remember, cosecant 7 pi over 6, the final answer will be negative 2. And I could provide any values. For example, if you really want to know what will be the secant of pi half, this line represents undefined values. So basically I'm saying there is no secant of pi half. Let's going to prove that situation. Okay. Once again, remember secant is the reciprocal value of cosine. Okay, so let's see. Hold on a second. Okay, again, 1 over cosine, because secant is the reciprocal value of the cosine. So, sorry. And as soon as you can see, cosine pi half, if we are doing well, actually the answer for this value, that's supposed to be a math error, because this is what we call asymptote, because there is no value in the unit circle that represents secant of pi half. Well, if you see, math error. That's because there is no value in this trigonometric function, okay? So basically the unit circle are useful to determine or for solving trigonometric equations, okay? The trigonometric equations. And what we require to solving trigonometric equations? Well, first of all, memorize the unit circle angle reference. And the second step will be we have a masterpiece in algebra, how to solving linear equations, quadratic equations, and sometimes we have to apply trigonometric equations to solving one of these problems, okay? Actually, this is going to solve a few examples to determine what will be the process to solving the trigonometric equations. All right. If you have some comments, please let me know in by means of WhatsApp or send me an email. Okay. Let's going to start. Let's going to solve, find all the solutions of the equations, okay? We have two examples. The first one, 2 sine theta minus 1 equals 0, and tangent square theta minus 3, that will be 0. The objective of these two equations is solve for theta, depending what will be the quadrants that will be located. For example, and by the way, your calculator must be set up in radius mode. But remember, the calculator will be unuseful because they're going to provide only one singular value in the first quadrant when the angle will be clockwise and counterclockwise. Remember, clockwise, that means the angle will be negative and counterclockwise will be positive. But in these trigonometric equations, we're going to working only with angles located counterclockwise. I mean positive angles. So basically, let's going to solve by theta. In this case, we have 2 sine theta minus 1 equals 0. You know, 2 sine theta, that will be 1. Sine theta will be equal 1/2. Okay, and theta will be equal the arc sine of positive 1/2. This is the moment of truth because at this moment, your copy already what will be the values of the angle provided by sine of theta that's supposed to give us 1/2. Okay, so basically in this answer, because 1/2 is positive, we're going to obtain two solutions, okay? Because sine of theta will be positive in the first and second quadrant. For that reason, the angles located in the first and second quadrant will be given by pi over 6 and 5 pi over 6. And because we really need to know to obtain the full solutions, okay, plus we're going to write always 2 pi k, where k represents any whole numbers. And this is going to be the solution set from theta. Why these two values? Because if you apply sine of pi over 6 and 5 pi over 6, both that will be equal 1/2. And why we are adding 2 pi k? Because 2 pi k represents the ending of the one singular point. Let me give you an excellent, a more detailed explanation with your calculator. For example, let me share the screen again. We have that sign, okay? Let's going to write sine of pi over 6. If we are doing well, the answer, that will be 1/2. We are checking that answer, okay? Equal, and the answer it will be voila. Well, we did so well. Now let's find out with 5 pi over 6. Well, because this is the angle, as soon as you can see, we have always the same results, okay? So for that reason, This is the way we're supposed to apply at the moment we're going to solving trigonometric equations. Let's go to apply in the second. And by the way, if you really want to apply arc sine of 1/2, and your calculator only gave us pi over 6, but never happens 5 pi over 6. For that reason, those values will be obtained of the unit circles. Okay. In the second one, let's go to solve for tangent. You know, tangent squared theta, that will be equal positive 3. Now, because we really want to know what will be the value of tangent, we're going to take square root in both sides, and tangent of theta will be equal positive negative square root over 3, square root of 3. Positive and negative. What does that mean? We're going to include the answers that will be provide the positive and negative values of tangent. I mean, the value of the theta will be equal the arctangent of positive negative square root of number 3. And what could be those angles? Those angles will be located in the full entire unit circle, because we have to include in which quadrants tangent will be positive. Well, tangent will be positive in the first and third quadrant. And which quadrants tangent will be negative? In the second and third quadrant. For that reason, those values that fulfill that result will be pi third, comma, 2 pi third, 4 pi third, and 5 pi third plus, and because the full complete period of the function tangent and cotangent won't be 2 pi k, that will be pi k. And this is going to be the solution set of this second trigonometric equations. If you want to check the answer once again, it's simple. Again, share the screen. We're going to share the screen. If you want to, if you really want to check that answer, that's simple. Let's going to apply parentheses, tangent. We can use 2 pi third, okay? 2 pi third. 2 pi third, close parentheses, elevated at the second, oh, sorry. Close parentheses, elevated at second power, and the result that will be positive 3. It doesn't matter because inside this equation there will be negative square root 3. Elevated the second power will be 3. And that's it. That's all that we have to do onto this part. Okay, let's going to solve another equation, another example. Let me do it. Let me find out what will be another example that will be useful for you guys. Let me see a little bit another complicated equations. For example, we have in the letter C. In the letter C, we have this trigonometric equations. 5 sine theta plus, times cosine theta plus 4 cosine theta, that will be equal 0. Okay, as soon as you can see, my dear students, okay, as soon as you can see, my dear students, the algebra, we're supposed to have a masterpiece of algebra. Again, how we can solve these equations? Simple. We can apply common factor. What will be the common factor? Is the factor whose repeat at the lowest frequency. In this case, cosine is repeat twice. I mean, one time over here and one time over there. Okay, so basically, at the moment, I'm going to apply cosine theta. Okay, cosine theta multiplying by Remember the original equation divided by the common factor. We got 5 times sine of theta plus 4. That will be equal 0. Okay. And what do we have to do onto this case? Well, simple. We're going to apply the null theorem factor. What does that mean? That means I'm going to equal any equation by 0. I mean, cosine theta equals 0 and 5 sine theta plus 4, that will be equal 0. In the first one, theta will be equal r cosine of 0. Okay? And if you check the values of the unit circle, the value who's provide cosine theta equals 0, the value of the angles that will be provided into this situation will be in the first one, pi half, and the second one will be 3 pi half. This is by one hand. By the other hand, if you really want to solve 5 sine of theta, that will be equal 4. Sine of theta will be negative 4 feet. But by this by this means, we're going to solve it for theta, and we got arc sine of theta of negative 4 feet. Okay, the answer according for this situation, solving the using the calculator. Okay, let me see. Again, it's going to share the screen. Okay, hold on. All right, share the screen. Let's see it. According for this situation will be, well, actually we have this calculator, okay? So as soon as you can see in the model, we got negative 0.93, the value of theta, okay? Negative 0.93 radians. And at the moment, you're going to provide the solution set is simple. The only thing that we have to do, because we have two values to represent the values, we're going to leave the negative value just like at 0.93 units, and the positive value, we're going to add 5. I mean, the solution set, theta 1 will be given by, in this case, pi half, and 3 pi half plus 2 pi k, okay? And the second value of theta, because this value doesn't belong the unit circle, will be given by negative 0.93 radians, comma, and the result for adding pi plus 0.93. That value will be pi plus 0.93. The result will be 4.07. 4.07 radians. Okay, this is gonna be the solution set of the second value. Okay, I don't know if you have some doubts or questions onto this part. If you have doubts or questions, don't hesitate to let me know, all right? So, and we got a third example. We have for the third example, the letter D. The equation could be given by 2 sine squared theta, 2 sine squared theta plus 5 sine theta, and basically we have negative 12, and this equation that will be equal 0. Okay, as soon as you can see, my dear students, this equation is a quadratic equation. Actually, this is a trinomial, the purpose square. Remember, every time that we have a trinomial or a quadratic equation, we can solve that equation in 3 ways. 3 ways. One of them, try and error, I mean the factorization. The second technique will be the completing a square, or the third one will be the quadratic formula. Okay, in that quickly way, we're going to try to solve that equation by means of the try and error technique. How can we do that? Simple. Let's try to find out a couple numbers so their product gave us 2. Well, actually 2 and 1. 2 sine theta and sine theta. We're going to copy. The first sign is positive. The second one will be the product between their signs. Positive times negative, that will be negative. Well, actually, we had to try to looking for a couple numbers of their product gave us 12. Remember, there's many combinations. One of them will be 12 and 1, could be 6 and 2, and another possibility will be 4 and 3. Basically, because the name of this method is try and error, we're supposed to choose one of these 3 combinations. Well, as a matter of speaking, I have no idea if you're going to resolve with the first try, but I'm going to decantate using the most balanced combination between them. That could be 3 and 4, and let's see what we got. How do I know if I'm doing well or wrong in this factorization? Simple. I'm going to multiply the string with the string and the middle with the middle. As soon as you can see the picture of this technique, is just like a happy face. If you are doing well, the point notice is to multiply the string with the string in the middle of the middle, the product of the addition or subtraction, that's supposed to be the number in the middle. Let's going to check this out. 2 times negative 4, that will be negative sine of theta. And another one, 3 times sine theta, that will be 3 sine theta. And negative 8 plus 3, that will be negative 5 sine of theta. Almost. We got 5 sine of theta, but the difference between them, this is positive and the result will be negative. For that reason, the only thing that I have to do is change the position of the signs. This is going to be negative, the other one will be positive, and as soon as you can see, 8 minus 3, that will be 5. So in this situation, we are pretty sure we are doing well this factorization. Now, how are we going to solve this equation? Simple. We're going to apply the null theorem factor. What does that mean? That means every equation will be equal with 0 to 0. 2 sine theta minus 3 equals 0, and sine theta plus 4 also will be equal 0. And there's a curiosity for the, if you remember the theoretical part of the trigonometric graph, the maximum amplitude or the maximum range between the functions sine and cosine, there will be positive negative 1, because sine and cosine are functions that strongly belongs to the unit circle. For that reason, the maximum amplitude for those values, sine and cosine, that will be 1. No more than that. No more than positive 1, no more than negative 1. What I'm telling this one, because if I really want to solve for sine theta up to this far, that will be 3.5. And this way will be negative 4. And if you want to try to looking for theta, that will be equal arc sine of 3.5, and theta equals arc sine of negative 4. My dear students, there is no solution. Actually, when you're trying to solve in these 2 equations in your calculator, that's not going to happen, because the sine and cosine functions will be provided only with the maximum values of 1. There is no inconvenience with cotangent, tangent, secant, and so on. But we're going to have a hard time at the moment to trying to solving equations, okay, using sine and cosine values that overpasses the value of 1. So basically, every time that we have values of sine and cosine that overpasses that 1, don't worry about it. The answer will be no solution. Okay, let's go into solving another example of these trigonometric equations. How do I know what will be the values of the unit circle? Well, actually, with the table that given a few seconds ago. Okay, remember you have the region you must copy and create your not an agenda and obtain to write at the region of your hand those values, because if you don't have those trigonometric actually unit circle angles by an exam, you will have you going to have having hard time to solving that problems. Okay, let's going to solve another equation. For example, in the letter E, we have 1 plus sine theta that will be equal to cosine square of theta. Okay, this is another example that we're supposed to solve. Ah, you're going to see, all right, but okay, mister, we have also quadratic equations. At the moment, we're going to move this quadratic equation to the right side, that we have one, let me change the value of this one. We have 1 plus sine theta minus 2 cosine squared theta that will be equal 0. Yeah, basically it's the first step. Equal the equation to 0. But this is a quadratic equation where we cannot perform in any of those techniques because cosine is a value totally different than sine. At the moment you're going to solve this trigonometric equations, make sure all of this stuff that's supposed to have or belongs to the same family, or you can have a mixture between them, but if and only if you have a multiplication of the terms. But in this case, doesn't accomplish the first method, neither the second one. Well, how can we solve in this equation? Well, this is a job for the trigonometric identities. Why? Because if you remember, we have that beautiful trigonometric identity, Pythagorean trigonometric identity. So we got sine squared theta plus cosine squared theta. That will be equal 1. And what happened if this formula we're going to solve it by cosine squared theta? Cosine squared theta will be equal 1 minus sine squared theta. Ooh, with this formula, that will be easier for us at the moment of solving this equation, because we can copy 1 plus sine theta, negative 2, and open parentheses, instead to write cosine squared theta, we're going to replace by that trigonometric identity. I mean, 1 minus sine squared theta, and the entire equation, that will be equal 0. What do we have to do? Well, let's going to apply distributive property. I mean, 1 plus sine theta minus 2 positive 2 sine squared theta. And the entire equation, that will be equal 0. Yeah, probably Marcela asking for, Mister, how do you get those values? Okay, it's simple. The only thing that we made, it's multiplying or applying distributive property. I mean, negative 2 multiplied by 1 and negative 2 multiplied by negative sine squared theta. Now let's going to apply like terms and arrange this trigonometric equation by canonical decreasing order. I mean, the highest power to the lowest power. I mean, the highest power will be given by 2 sine squared theta plus sine of theta, and 1 minus 2, that will be negative 1. And this result, that will be equal to 0. And basically, we are changing the original trigonometric equation. Actually, this is a quadratic equation by another quadratic equation using the same family. Well, in this case, we can apply again, try and error technique, completing the square or quadratic formula. It's up to you. Whatever you want to use to solving quadratic equations, you're free to use it, okay? I'm strongly recommend using try and error technique because it's a quickly way how we can solve this kind of equations. So again, give me a good numbers, multiplying gave us 2. Okay, we have 2 sine theta. Copy the first sign is positive, and the second one, sine theta. And positive times negative will be negative. Now a couple numbers whose product gave us 1 will be 1 and 1. Okay? If you really want to check if we are doing well or wrong, we're going to apply the same technique applied over there. Extreme with extreme, and the middle with the middle. We're forming a happy face. If we're doing well, the answer for subtracting, because we have different sign, that's supposed to give us negative, positive sign. Let's see what we got. 2 sine theta times negative 1, that will be negative 2 sine theta. And 1 times sine theta, that will be positive sine theta. And 2 minus 1, negative 2 plus 1, that will be negative sine theta. Almost. That's supposed to be positive. Well, basically, the only thing that we have to do is change the value of the signs. That will be negative, and this position will be positive. And because we have this arrangement, positive, negative, and the result will be positive. We are doing well up to this part. So let's going to finish this. 2 sine theta minus 1 will be equal 0. Remember the null theorem factor. By the other hand, sine theta plus 1, that will be equal to 0. Solving for sine theta. 2 sine theta equals 1. Sine theta will be equals 1/2. For that reason, theta will be arcsine of positive 1/2. And this value belongs to the unit circle. Once again, remember, the sine function will be positive in the first and second quadrant. In the arcsine of 1/2, that will be pi 6, comma, pi 6, comma, positive 2 pi k. This is going to be the first solution set of this equation. This is by one hand. Yeah. Where I got those values? In the unit circle table that you copied a few seconds ago. I'm mentioning for only for the doubts. If you're asking again, how, Mister, I don't understand how you're going to take those values again by means of the use of the tables of the unit circle. And by the other hand, sine theta, that will be equal negative 1. Theta will be given by the arcsine of negative 1. And please, would you like to tell me what will be the only value, the one value, I guess, the only one who's provided negative 1 in the unit circle? Yes, there's only one, and you're right. That will be 3 pi half. This is the only value in one singular period that in the unit circle gave us negative 1, 3 pi half. And as soon as you can see, this is not complicated thing. The only thing that you must do is, actually the hardest part on this situation will be learning the trigonometric identities, applying the unit circle, and that's it. That's all that we have to do. We have another example again. Basically, after this lesson, you are available to complete your homework. I know the homework's for tomorrow, Monday, March 13th. With this lesson, there will be more than enough because the rest of the homework, they have been explained it already. Well, onto this situation, let's go to finish this. We have the letter F. For example, we got sine of 2 times theta. Check this out. Sine 2 theta, no sine square, minus cosine theta. That will be equal 0. That will be equal 0. How can we solve in this trigonometric equations? Well, once again, the only thing that we must do is applying the trigonometric identities because sine of 2 theta is a double angle trigonometric identity. Yes or no? Of course. I know Sylvia got the right answer. Yeah, you're doing well. Now, let's going to change sine of 2 theta. It's twice sine theta, cosine theta, subtracting cosine theta because sine of 2 theta is a double angle trigonometric identity. What do we have to do? Well, until this part, we can take the common factor. This common factor will be cosine theta, and the result will be obtained divided the original equation by the common factor. I mean, this the first three elements by cosine theta, that will be 2 sine theta minus cosine theta divided by cosine theta, that will be 1. And we are factorizing already. I hope, if God wills, I don't know, Gabriel is waking after this part of the lesson, and probably Mariana is falling to sleep. Maybe yes, maybe not. Probably everybody's laughing at this moment, but if you have doubts or questions, don't hesitate to let me know. And how do I get this common factor? Remember, the original equation divided by cosine. 2 sine theta, cosine theta divided by cosine theta, cancel cosine, you got 2 sine theta. And negative cosine divided by cosine, that will be -1. What do we have to do into this part? Simple, applying the Newtonian factor. I mean, every equation equals to 0. Cosine theta equals 0. 2 sine theta minus 1, that will be equal 0. Okay? Let's going to solve for theta. Theta equals arc cosine of 0. And you know, the values that provide cosine arc cosine of 0 in the unit circle will be given by pi half, 3 pi half, plus 2 pi k. We have the first solution of this value theta. This is by one hand. By the other hand, we have 2 sine theta, that will be equal 1. Sine theta will be equal 1/2, and theta will be arc sine of 1/2. Well, as soon as you can see, we repeat this equation already. That's supposed to be pi 6, pi 6, comma positive 2 pi k. And that's it. That's all that we have to do on to solving this trigonometric equations. Okay, let's see if we're solving one more try. One more try. This is gonna be a nice, the last one. This is not complicated thing, but sometimes you're going to use your imagination, the algebra concepts, how to solving those equations. I'm going to rate this part of the whiteboard. I think you copied that one already. Okay. And let's see what we got. This is interesting trigonometric equations. Okay. For example, in the letter G and the last one, we have cosine theta plus 1. That will be equal sine of theta. Yeah, sine of theta. Good. The question is how we can solving this trigonometric equation, because it doesn't matter how we can do that situation. There is no trigonometric identity for sine theta, neither for cosine theta. One could be sine squared plus cosine squared. But this is by one hand. By the other hand, or basic trigonometric identity is given by the unit circle or the Pythagorean theorem. Sine squared theta plus cosine squared theta will be equal 1. If I have this sine squared theta, that will be easier for us because at the moment we're going to solve it by sine squared theta, or trigonometric identity for this function will be given by 1 minus cosine squared theta, right? But this is a pain in the neck. Why? Because unfortunately, there is no square values. Well, but in algebra, we have a one singular advantage. If you don't know how to solve these equations, you can, how to say that, we can use your imaginations for our created inventions that will be provide a solution for this case. Because the missing part to solve this equation, that's supposed to be a second power, we can perfectly well elevate at the second power both sides of the equation. What's going to happen? In the right side, we're going to transform sine theta like a sine squared theta, right? This is by one hand. By the other hand, because I have cosine theta plus 1, we can apply a special product. Remember, the special product formula is given by the equation a plus b second power that will be equal a squared plus 2 times ab plus b squared. So basically, cosine that will be 8 and 1 that will be b. For that reason, we're going to obtain cosine squared theta plus twice cosine theta plus 1. That will be equal sine squared theta. Excellent. And this sine squared theta, that's adding positive subtracting. And we got cosine squared theta plus 2 times cosine theta plus 1 minus sine squared theta, that will be equal 1. Okie dokie. We have an interesting thing. I don't know if you see that already. Can you see this part of the equation? 1 minus sine squared theta? Yes or no? I hope you saw that already, because if we're solving, instead of solving for sine squared theta, we're solving for cosine squared theta, that will be equal 1 minus sine squared theta, right? And basically, 1 minus sine squared theta, that will be cosine squared theta. So onto this part, we can change this equation by cosine squared theta. I'm going to copy again, cosine squared theta plus 2 cosine theta plus cosine squared theta, that will be equal 0. Excellent. As soon as you can see, we got like terms. Cosine squared plus cosine squared, no. It won't be cosine fourth power, no. 1 plus 1, that will be 2 cosine squared theta plus 2 cosine theta, that will be equal 0. How can we solve this equation? Simple, we can take the common factor. Obviously, will be 2 cosine theta, open parentheses, that will be cosine theta plus 1 equal to 0. Why? Remember the original equation divided by the common factor. 2 cosine squared theta divided by 2 cosine theta, that will be cosine theta. And 2 cosine theta divided by 2 cosine theta, that will be positive 1. Okay? Now, applying the null theorem factor, 2 cosine theta will be equal 0. Cosine theta plus 1 will be equal 0. Cosine theta will be also 0. Theta will be arc cosine of 0. And what values are provided by 0? In cosine, simple. That will be pi half and 3 pi half plus 2 pi k. This is the solution set for one hand. By the other hand, cosine theta will be equal -1. Theta will be our cosine of -1. And what will be the only value in the unit circle of the angle of cosine will be -1, the answer. 3, 2, 1, that will be right. Pi. This is the only value that will be provide the answer from cosine. And that's it, my dear students. That's all that we have to do to solving trigonometric equations. And you know how we're going to apply the relationship between the unit circle and those equations. Thank you so much for your attendance. If God wills, I'll see you tomorrow. Have a good meal. Take care of yourself.